Fatoo Lemma is an incredible, powerful tool when it comes to uh, integration of real valued functions, whether it's Riemann integral of Lebesgue integral. Okay, so it will play a major role. So it's good. It comes as a result of the previous convergence theorems. Okay, and the idea is always to come back with a monotone sequence that converges to something, and then that's how you get it. So in any case, so what do we have? We have a sequence of functions. So here, let the fn's defined on AB. So what do we have? We assume that they are a Riemann integrable. Okay, and we assume that they converge pointwise. So the fn converge pointwise to f, and f is Riemann integrable. So the claim is that the integral from a to b of f of x dx is less or equal than lim inf when n goes to infinity of fn of x dx. Okay? Clearly, if the lim inf here is equal to infinity, then there's nothing to prove. Okay? So what we are going to do is to assume that the uh, lim inf, so we'll assume that lim infimum of the integral of a to b f of x dx when n goes to infinity is finite. Okay? So in this case, okay, uh, going to the properties of the lim inf of numbers, remember these are just numbers, so we're looking at the lim inf of a sequence of numbers. So there exists a sequence nk of integers such that lim inf limit of when nk goes to infinity of the integral of a to b of f and k is exactly the lim inf of the sequence. Okay, so there is a subsequence of numbers such that you have the limit equal to that. Okay, so now obviously the subsequence f and k, the subsequence also converges pointwise to f. Okay, great. So now from this subsequence, okay, which converges pointwise, we are gonna consider a sequence which is increasing smaller. Huh? So we'll introduce h n I to be the infimum of f n k, okay, for nk greater than ni. Okay, so it's easy to see that the h and I of x, this sequence here, is monotone increasing. And converges pointwise to f. Okay, so now we can use they are not Riemann integrable. So the h and i's are not. Okay, so we can use the Luxembourg monotone convergence theorem, and we know that the limit, okay, when n k goes to infinity of the lower integrals of h and k of x dx is equal to the integral from a to b of f of x dx, because f is Riemann integrable. Okay. Moreover, we know that hnk of x is less or equal than fnk of x. Therefore, the lower Riemann integrable of hnk x dx will be less than the integral, because the fn's are Riemann integrable. So here it will be fnk of x dx. Okay? Therefore, if we consider the limit, we'll find that the limit, the integral from a to b, which is the limit of the hnk, is going to be less or equal than the limit of the integral from a to b of the fnk of x dx, which is equal to the lim inf of the integrals of the fn of x dx when n goes to infinity.